ahead and share this. Okay, so those of you that are here, can you hear me okay and see my screen?
Yeah.
Okay. Okay, so again, just to point out the specifics about the test, it's from 4.5 to 4.7 technically, although some of the background trig information you certainly have to know, but it's lessons 48 to 53. It is 50 points, 16 questions, although not every question is created equally. I think there's a couple of multiple choice and then maybe one or two that have multiple parts. So 16 questions, whatever that means to you. And remember, it's non-graphing calculators only. So I'll start with what Zach was mentioning about the four trig functions other than the sine and cosine. So if you take a look here, these are the tangent, the cosecant, the secant, and the cotangent. You have them not only here in class notebook, you have them on the back of your salmon colored sheet. You also have them in lesson 48. Lesson 48 is where we kind of graph them one point at a time, and when we went through the full-on analysis. So you should first and foremost be able to recognize each of these parent functions just by sight. So if you look at the way these are set up, the cosecant is the reciprocal of the sine, the secant is the reciprocal of the cosine, and then the cotangent is the reciprocal of the tangent. I would imagine at this point you have the sine and the cosine on lockdown. As far as the cosecant, because of the fact that the cosecant is 1 over sine, anywhere that the sine graph has a 0 or an x-intercept, you know that that is where the cosecant is going to have the asymptote. And again, that's important just in case you were asked to recognize it just on site. Compare that to the cosine graph. Anywhere that the cosine graph has a x-intercept, that is where those asymptotes are going to be. So again, let's say that I gave you one of these and you weren't sure which one it was. If it goes through the y-axis, you know that it has to be secant. If it doesn't go through the y-axis, you know that it has to be cosecant. Even more than that, it's really this point 0, 1 that tells you the story, because this 0, 1, if you do 1 over 1, you get 1. So that's how you know which graph matches up with the cosine as opposed to which one matches up with the sine. When it comes to the tangents, again, if you can remember that the tangent kind of looks like the cubic, but it starts down here in the negative and then scoops up to the positive. If you know that the tangent does that, you should hopefully be able to remember that the tangent goes the opposite direction. As far as all of this information goes, you'll have a graph in front of you of some kind, whether I give you the parent function and ask you to transform it, or whether I give you a transformed function. You should be able to answer those questions simply by looking at it. Really, the only other thing you want to be mindful of is that the sine, the cos, the secant, and the cosecant all have periods of 2 pi, where the tangent and the cotangent are pi only. So if I gave you one of these 6 graphs and I said, which one is it? Sine, cosine, tangent, etc., you should be able to tell me based on the fact that hopefully you will have studied the parent functions. Some of what I might ask you to do, okay? So underneath here, I have for you 1/2 times the cotangent of 3x. So in fact, let me just go ahead and get the parent function and put it right next to it. So the cotangent graph is this one right here. So let's say that I was to give you this transformed graph of 1/2 times the cotangent of 3x. I would want you to be able to tell me what the transformations do and then answer questions to analyze the graph. You again might want to start by highlighting any asymptotes. If you're someone who's been using colors or highlighters, you're welcome to continue doing that. So here are all the asymptotes, give or take. Compared to the original function, this 1/2 is a change in amplitude, also known as a vertical shrink of a 1/2. The truth is, a vertical shrink of a 1/2, you can't really tell. It doesn't really look like a big change because of the fact that the range is all real numbers. So if you're vertically shrinking the y's by 1/2, they're still going to be all real numbers. So you can't really see that there's a change, although there is one. Certainly this 3, you would hopefully identify that 3 represents the b value. In order to find the new period, remember that you do the old period divided by b. In this case, the old period of the cotangent is pi. So pi over 3 should be your new period. And if you want to confirm that, the definition of the period is exactly how long it should take to go through one full cycle. So if you look at this wave right here, it goes from 0 to pi over 3. That's a period of pi over 3. If you look at this cycle, it goes from pi over 3 to 2 pi over 3, which is also a distance of pi over 3. Again, the period is the distance, in this case, from asymptote to asymptote, pi over 3 in each of those circumstances. So again, things that you should be able to tell me, you should be able to describe the blue and the green transformation. You should be able to tell me what's the new domain, the new range, the new period. We already talked about the fact that the range would still be all real numbers. The new period would be pi over 3. If you were talking about domain, x cannot equal, because of the fact that all the yellow asymptotes are at 0, pi over 3, 2 pi over 3, negative pi over 3. Those appear to be the multiples of pi over 3. So you would say that the domain is x cannot equal pi over 3n. Remember, there are infinitely many answers that you could write. You could say pi over 3n. You could also say pi over 3 plus pi over 3n. That would mean that if you start at pi over 3 and you keep adding pi over 3's in each direction, you should get all the asymptotes. And you could also set this up for any starting asymptote, and then how far is it to the next one. So Zach, probably that's what you meant when you said, can we talk about the cotangent, tangent, etc. But if there's anything else you want me to go over, I will. I have one more underneath, but does anybody have a question? Again, I am not asking you to graph any of the other 4 trig functions from scratch. You only have to be able to analyze them. Either I can give you the transformed function and ask you about it, or I can give you the parent function and ask you what would change under the transformations. If you want to see one more, this one here is a cosecant. And again, let me just, for make it easier, let me go back here and snip the cosecant so that we can see it. So if the cosecant graph is supposed to look like this, and now I'm asking you to consider the negative cosecant of 4 pi x, there are 2 transformations that are happening here as well. The first one in purple, this negative, means that there is a reflection over the x-axis, which should hopefully make sense because normally the first u goes up and then down. Here it's starting by going down and then flipping up. This 4 pi, the whole 4 pi, hopefully you would be able to identify that as your b. Remember that to find the new period, it's the old period divided by b. For the cosecant, the old period is 2 pi. So you would go ahead and do 2 pi divided by 4 pi. Cancel the pi's. Simplify 2 over 4, and the period should be 1/4. And again, what that means, that the period is 1/4, is that one full cycle of the graph, which means one full up-down motion or down-up motion, should exist between 0 and a half and 1, or 1/4. So it should, 1/2. I think I said it right, but wrote it wrong. So that simplifies to be 1/2. So again, the fact that that's the period means that from 0 to a half, you should have one full up-down motion, or again, in this case, down-up motion. Here is your second cycle between a half and 1. Here is your third cycle between 1 and 1.5. So again, the period is the length of one full cycle. From here, I could ask you for the domain, the range, the x-intercepts, anything that I asked for you originally. When it comes to the range, notice that the range has not changed. It's still negative infinity to negative 1, and then 1 to infinity. There is a bit of a change as far as the period goes, or as far as the domain goes. So as far as the domain goes, x cannot equal. You would go ahead and try to find out where the asymptotes are. So I see an asymptote here at 0. I see an asymptote here at 0.25, 0.5, 0.75, and then so on and so forth in both directions. In this case, it looks like that the domain is x cannot equal multiples of 0.25. So you could say that that was 0.25n. You could also say 0.25 plus 0.25n, or anything that's equivalent. So Zach, did that answer your question? And if not, anything more specific that I can do for you? Okay, I don't want to put you on the spot. Let me go back and see if there were any other specific questions that anybody sent. Okay, Zach says that that's good. If anybody else has anything, let me know. Otherwise, let me go ahead and address a question that someone had sent earlier. So the question that someone had asked me to do earlier was about inverses, and specifically those that required variables. So in the review sheet, the ones that were kind of that the ones that were kind of in that vein were the ones at the bottom of the review sheet here. So let me just go ahead and find some of those. Remember, there's really only two different kinds of problems I can ask you as far as inverses go. I can ask you to do those from the unit circle, or I can ask you to do the ones that require drawing a triangle. And the truth is, these are all the same type. You have to draw a triangle for each one. One will just be all variables, where the other one will have actual numbers. So I think we did a number one in class. And again, someone specifically had asked about the variables. So let me go ahead and do 131, for example. So if I'm going to do 131, you're going to use U substitution, and then you're going to go ahead and solve for the expression. So this is a composition. You're going to go ahead and work from the inside out. So if you're going to work from the inside out, you're going to start with this right here, and you're going to let that be your U. So U would be equal to the arc cosine of x over 2. In order to get rid of the arc cosine, you're going to take the cosine of both sides. So the cosine of U equals the cosine of an arc sine cancels, and you're going to get x over 2. So once you have it down to a sine, a cosine, a tangent, or really any of the six, you'll be able to realize that a cosine is an adjacent over a hypotenuse. You could also think of it as being an x over an r, depending on which way you're remembering it. This is an arc cosine of positive x over 2. Arc cosines can only exist in quadrant 1 or quadrant 2. The fact that it's a positive arc cosine is how you know it's quadrant 1, because cosines are negative in quadrant 2. So you're going to draw yourself a triangle in quadrant 1. Your U always has to come from the origin. Because the cosine of U is equal to the adjacent over the hypotenuse, or the x over the r, you're going to go ahead and assign the sides as such. In order to finish this, you have to find the third side. So you can think of the third side as y. Remember that x squared plus y squared equals r squared. So x squared plus y squared equals 2 squared. That would mean that y squared is equal to 4 minus x squared. The way that you get rid of a squared is by taking the square root. Normally it's plus or minus, but because you're in the first quadrant, it will obviously be the positive. So you're going to replace the y with the square root of 4 minus x squared. Now, as I've mentioned, if your underneath the radical is a binomial, which it always will be, you do not know the square root of it. It is not 2 plus x. It is not 2 minus x. It is not something that you know, so you simply just leave it. Last but not least, after you have drawn the triangle in the appropriate quadrant and found the third side, go back and finish the question. This was a tangent of the inside, which you turned into the tangent of U. So the tangent is the opposite over the adjacent, or the x over the or the y over the x. So the opposite is 4 minus x squared square rooted all over x. That could be your final answer. It's perfectly fine to have a radical in the top, but if it was in the bottom, you would go ahead and rationalize. So similar process for any of these. And again, if you want to just kind of look at them, if you look at number 27, this is a positive 3/4. Because arctangents are quadrants 1 or 4, you would know that this is quadrant 1. This is a positive arc cosine, which again could be quadrant 1 or 2. Positive means quadrant 1. This is a positive arctangent, 1 or 4 would be 1. This is a negative arcsine, quadrant 1 or 4 would have to be 4. So use substitution, draw a triangle in the appropriate quadrant, find the third side, and then calculate the outside ratio. I mean, honestly, the worst thing that could happen, I think, in these problems, considering we've done so many of them, is let's say you drew them in the wrong quadrant. Your answer should still be right, except for the possible plus or minus. Let's say you accidentally thought a cosine was a y over an r. You would have the correct 3 sides, but just in the wrong spot. So in any of those circumstances, you would still get the majority of the credit as long as you were able to set a u, draw a triangle, find the third side, and then calculate. So I think the questions people have asked so far have been good, but I definitely think that what you've asked me so far is, the secondary stuff. The main focus, I would say 60% of the test focuses on graphing the sine and cosine wave, telling me things about the sine and cosine wave, finding the equation, and then word problem applications. I would say that this other stuff is probably the remaining 40%, and I would say it's probably 20% of the inverses and 20% of the other graphs. So other questions that I can go over for you? Let me see if anybody's still here. I mean, it looks like we've got a couple people. Who knows? Maybe people walked away or whatever. But if anybody has anything, let me know. Otherwise, I'll just pick a few more random problems. And if nobody has anything in the next couple of minutes, then we don't have to belabor it. But let me go back to the review sheet here. Again, just looking at the review sheet in general, we just did some of the inverse problems, and the truth is, I don't know that there's all that much to it. When it comes to anything related to the other 4 trig functions, hopefully what I just went over made sense. If I'm going to go ahead and do one of the ones here, why don't I go ahead and do number 3? They're all probably just as good, but let me go ahead and do number 3 here, just to make sure you understand what it is I'm looking for. So if I'm going to go ahead and do number 3, hopefully you are able to tell me that this is the A, this is the B, this entire thing, including the positive, is the C, where this is the D. So the amplitude is 3, the midline is -2. When it comes to the period, remember that the formula for period is the old period, 2 pi over b. So the period is pi. When it comes to the phase shift is -c. So negative pi over 2. When you go to set up your x's, and I'm just going to let you draw it freehand tomorrow as well, you're going to want to make sure that you always start at the phase shift. Even if the phase shift is 0, you have to start there. So I'm going to start this at negative pi over 2. In order to find the 5th point, you have to do the phase shift plus the period. So you have to add pi to negative pi over 2. If you're going to add pi to negative pi over 2, probably makes sense to write this as 2 pi over 2. So if you add 2 pi over 2 to negative pi over 2, you get pi over 2. In order to find the point in the middle, you would add the ends and divide by 2, which is nice because that's 0. That actually means that this is where the y-axis is. Sometimes, again, I recommend not putting the y-axis in until you know for sure where it lives. Then you do the midpoints. So if you add 0 to pi over 2, you get pi over 2. Because the numerator is odd, 1 pi, half of 1 pi over 2, double the bottom, is pi over 4. 0 plus negative pi over 2, because the top is odd, again, double the bottom, negative pi over 4. So in this problem, the midline is at -2. I like to kind of draw it as a dotted line. You can do whatever works best for you. Then this is a +3 amplitude. So we know that this graph has to beginning, middle, and end on the midline. You have to go up 1, 2, 3 to find the maximum. You have to go down 1, 2, 3 to find the minimum. and this graph has to exist from negative pi over 2 to pi over 2. Please make sure that tomorrow I can see your 5 x values. Make sure that they are reduced, and then make sure that your y values are either labeled or obvious from the graph. Obviously, these can get a little bit complicated if they turn super fractiony, but the truth is I'm not going to ask you to graph a whole lot of them from scratch. We already had a mini quiz on this, so I don't know how many more I actually need you to complete. Just a general note, let's say that the phase shift wound up being pi over 8, and let's say you had to add a period of pi over 2 to it. Obviously, the way that you add those values is by using a common denominator, which would be 8. So this would be pi over 8 multiplied by 4 plus 4 pi over 8 would be 5 pi over 8. So don't forget how to do your easy math, just your addition and subtraction of fractions. Additionally, when it comes to midpoints, remember there are really 2 main things that can happen. You can add 2 points and you can get something like 2 pi over 5, where the numerator is even. If you have an even numerator and you're trying to turn it into the midpoint, you take half of the numerator, which would be 1 pi over 5. So again, 1 pi over 5 is half of 2 pi over 5. Compare that to pi over 3. If you had pi over 3, where the numerator is odd, 1 is odd, you're going to double the bottom. So half of pi over 3 would be pi over 6. I would implore you, when you go to set up your x's, please just make sure that it makes sense. If you had something like pi over 6 followed by 5 pi over 6 followed by pi over 2, it should stand to reason that that does not make sense, because this value here is smaller than 5 pi over 6. So certainly these values would have to be inverted. So again, please just use a little bit of common sense. Let me go ahead and also do one in reverse. So again, working in reverse means I give you the graph and you write the equation. It's my other page. So we had talked about the fact that for now that you know phase shifts, you could technically write each of these with infinitely many answers. My advice is to either try to find the easiest one, or if I tell you specifically that you have to do sine or cosine, obviously do that one. So let's say here that we're going to do this problem right here. If I don't specify sine or cosine, I would go ahead and I would look at this and I would say, okay, this entire thing is required for the wave. So from negative pi over 6 to pi over 2. Keeping that in mind, I would say to myself, okay, this is obviously a negative sine wave. And I know that it's a negative sine wave because it goes down first and then goes up. In terms of the other values, the midline is here at 0. So this would be plus 0, which you don't have to write, but let me just write it there for a placeholder. Remember, the amplitude is the distance from the midline up or the midline down, so that's pretty clearly 2. In order to calculate the b, you would have to set the formula for period 2 pi over b equal to the period. So the period is the distance from the beginning to the end. So in order to find that distance from the beginning to the end, you would do pi over 2 minus negative pi over 6. That's how you find a distance. It's the back minus the front. A negative negative becomes a positive. In order to add these, you would do a common denominator. So this would be 3 pi plus pi, which means 4 pi over 6, which would reduce to be 2 pi over 3. And again, this is the period, which is the distance from the beginning to the end. So if 2 pi over b is equal to 2 pi over 3, you know that the b is 3. Last but not least, what is the shift? So normally a sine wave starts on the y-axis. If you are writing specifically this wave, it went pi over 6 to the left. And the way that you say pi over 6 to the left is x plus pi over 6. So here would be your answer. And again, you do not have to put the 0 for the midline, but you just might want to use it as placeholder. So feels like we hit most stuff other than the word problems. So these word problems are slightly different than the ones that we had done in class. And tomorrow you might see ones that are even different still. But I promise I did try to pick concepts that you were familiar with. Again, just general things to point out, unless somebody has a specific problem that they'd like to do, in which case I'd be happy to. If you're trying to determine if it's sine or cosine, I might tell you, or you might get to pick, or there might be a piece of information that you have to carefully find. So if they're telling you that the displacement at 0 is 0, you know that that's a sine wave because it goes through 0, 0. In the next one, if they're telling you that the displacement at 0 is at the maximum, that's how you know that it's a cosine. And in fact, that's how you know that it's a positive cosine, because you're starting at the maximum, which implies that it would only get smaller from there. In the next one, when they tell you that the spring is compressed, so it's 5 centimeters above the rest position, again, that is how you know that this is a cosine. The only way that it can be a sine is if it's at rest, if it's at 0, 0. Here they give you a graph. They're showing you the deer population. They ask you to find an equation, and then they ask you to explain what it means. So if you were going to try to write the easiest equation, I would probably write this one. I think you could say with confidence that from 0 to 8, there is a negative sine wave. The D value or midline would be 500, and the amplitude would be 300. If you were trying to describe to me why that happens, I mean, again, I think you should have some idea of what, population and how it works. So basically 500 deer is the baseline population. At some point that number goes down, probably in the winter or the hunting season. Once the hunting season is over and there aren't any more predators, the number of deers increases to its maximum, which is 800, and then the cycle kind of starts again. So you could describe this behavior, again, based on weather, based on predator and prey habits. It doesn't have to be super specific, but I think that's probably something reasonable. Here, for the last two, for number 14 is mostly pointing out the fact that this 500 pi cannot be there. This will only work, the rules, if you factor out that 500 pi. If you factor out that 500 pi, you get t minus. In order to figure out what you're left with, you're going to do this value divided by this value. So 100 divided by 500 pi. The 100 would cancel, would be 1 over 5 pi. So make sure that you can factor. Really, I don't think you'll see anything harder than that. Clearly, this is a sine because they say it's a sine. Here it's a sine because they say it's a sine. And I would say the last thing that I'd want to point out is this idea of frequency. Remember that frequency is how often something occurs. The frequency is equal to the reciprocal of the period, or 1 over the period. So for example, if I said to you that the period was equal to 6, the frequency would have to be equal to 1/6. If I said to you that the period was equal to 2 pi over 7, you could say that the frequency was equal to 7 over 2 pi. So again, you want to think of it as either a reciprocal or a 1 over, depending on the format that you're given. So I really do think that kind of hit everything, but I am still happy to go back and talk about anything else if there are any additional requests. So are there any additional requests? Again, I do think that if you're able to do this review sheet, you should be more than fine for tomorrow. You're going to have the small calculators with no graphing. You're going to need to be in radian mode for the test, which I will remind you of. But really, if you can do this review sheet, I think you should be in good shape. And I don't think that time will really be a huge factor. So you can plan to, have time to check stuff over. So going back here, I thank you for coming. Looks like we've got a couple of people. If anybody has any other questions that they were too shy to ask and want to send me a chat right now, feel free. Otherwise, I think hopefully that should do it, and I'll go ahead and post this. So thanks for coming. And for those of you who have your test on Wednesday, feel free to send me, chats tomorrow, and I will get back to you. Otherwise, you're free to go. Thank you for coming, and good luck.
Thank you.
All right. Thanks, guys.